Hello guys, it's Boris here. I hope you're doing really well. Let me uh, explain you what we will do today. We will extend our software service calculator application, which we have implemented earlier. If you don't have the implementation, I will pass a link to the video in the description of this video. So first we need to install Redis locally or use Docker to start an image of Redis. So both ways need steps. In the first case we need to install Docker, in the other case we need to install Redis. So we will pick the first one. We will install Redis on our local machines, but it's up to you. I will show you how to do it with the Docker too. So you can write in your browser search bar install Redis server, and there's type here the install Redis docs here, and you can see there is an explanation how to install Redis on Linux, on macOS and Windows. Here are the links. It's very easy. I have followed the Mac installation with the brew tool, and if you use Windows, just go and click here. There is step-by-step explanation. So for Linux it's the same, and it's really easy. You need to install Redis inside for the client server part, to browse the database, and if you see, my server is running on the localhost right now. If I stop it, right, I should not connect now. Yeah, we have an error, we cannot connect to the server. So this is the command to start a server on Mac, and I can connect again. We don't have keys now, hashed keys. So this is a practical tutorial. We will explain what Redis is in a later video if you want, but I know everyone want to do the practice first. It's more interesting. So this is the first step. Install Redis on your local host. Install Redis inside to browse your database to see what you're persisting there. And this is our application, the calculator machine application. Like say, I will pass a link to the video where we have implemented this, and I'll start the application now. To have a recap, what we have done here is the functionalities. We expose one endpoint calculate on this URI, and we pass some number and rise to the power, some power. So 2 rise by 2 is 4, right? So let's check this. The result is 4. We have composite DTO here, which have information from the number passed and the power, and we have the result. So this is the implementation of the service, and we have some security configurations, we have Swagger, if you remember, and so on. Okay, this is not so important right now in this video. Let us start by configuring the Redis into our Spring Boot project. It's not really intuitive and easy. if you try searching on the web, you will find that there is no much information accumulated in one place to do it in from one reading and just do it. So uh, we want Redis package. Under configuration we want Redis config class. We want this class to be configuration class type, define beans in it. We can choose from two clients here to connect to the Redis server, and the first one is this let use connection, and the other one is Redis connection factory. You can browse it here, Redis connection factory, and the other one is let use connection factory. So it's up to you which one you will use. In this video we will use this one. Let's define it. Now we don't have the, you can see we cannot import it, we don't have the dependency, but I have the dependencies saved here. Now this standard we need Spring Boot starter data GPA to using the repositories of Spring Boot, the GPQL, and there's a little trick there you'll see right now. I'll put the dependency right here. I'll define it in the POM file, and now when we start the application again, let us make a pin install. Okay, for now let's just comment this out. Okay, you can see now we have an error. It says we don't have a data source. We cannot create a data source bin, which is provided by default by the Spring, because it failed to find a suitable driver class. For example, a class for MySQL, PostgreSQL, H2 in memory database, so on. We don't need this here, and the trick here is to use this annotation. We should exclude the auto configuration for this, and this will allow us to continue without Spring complaining about this driver, because we don't need to use this driver. Nor MySQL nor PostgreSQL, we don't need this. So this should work now. Let's run the application. Okay, you can see we don't have this error right now. Why we just don't remove this dependency? Because we need GPQL here. We need the Java persistent query language to define repositories, and so we do this trick here. And now what other dependencies we need? We need let use core and Spring Boot starter data Redis, and like I said, we can use other client here, the Redis one. So let's uncomment. Let's first review the project because we need the dependencies to be picked up. Okay, let me uncomment this. And now, okay, you see we cannot import it. This is IntelliJ related now. There is no import. So we do this invalidate caches, clear file system cache and local history, and we do a restart to the IDE. Now we can do the import. Okay, now IntelliJ do some indexing. Meanwhile, what we say here, this connection factory, to create new connection factory with ready standalone configuration for the local host and this port. So we have Reduce core, we have Spring Boot starter data GPA, we have Spring Boot starter data Redis. Those are the three new dependencies which we will need to implement the Redis configuration here. And okay, let me try again. Sorry, we have imported right now, and let me import this also. Okay, sorry. Now we have the Redis configuration, the factory, just the factory. Now we need the REST template. You can know the REST template is needed even if you use databases like MySQL or PostgreSQL. This template provides us with the client to communicate with the database, and we don't need this naming here, explicit naming. And now what we are doing here, we define the template by setting the connection factory, which is this bin. You can see the name here is this name, otherwise it will not work. You can put a qualifier here and say, hey, use this bin, but this is not needed. We set the connection factory. We need serialization and for the key and the value. Actually, we need here string ready serialization. Okay, sorry, string class. Okay, Okay, we are fine right now. So we have the REST template defined, and we need to enable Redis repositories by this annotation. Enable okay, I think this is enough. So after that we need to define an entity here. Let me define one more package entity. Okay, and this will be a result entity class. We use the annotation Redis hash here. We can give it a name, result, for example, and we need ID here, which should come with from this package right here. Okay, from this package, Spring Framework Data Annotation, because we don't have Jakarta right now, and it will complain that we don't have this package if you use Jakarta. So we need this ID for sure for Redis to work, and we want to have a result DTO here. Yes, result DTO. Okay, we want to import this. Just a second. Yeah, it's with uppercase. Sorry. We want the result DTO to be persisted in the Redis hash. Okay. This will be the key for the entities, for these entities, for those entities in Redis. This will be persisted, the input and the result, and to allow this, the persistence in Redis, we should implement serializable here and here, because the result DTO use the composition of input DTO, it also should implement serializable, because from this class, for example, you have Java class, right? We have some Java class, for example, this one. Okay, and Redis serialize this into bytes. It is serialized into bytes before it is persistent into Redis. So we should implement serializable here for this object. Okay, this is the case why we need those annotations right now. Okay, let us continue. We have the entity, and we should use Lombok annotation date here. Let us create a constructor, not from Lombok, explicit constructor. Okay. So we'll be using the ID for the number, which is put in the input right here, because we don't want to recalculate, but it I will tell you why this is not correct in our business logic. But let us do this work first. So we have the Redis configuration. We has a result entity, and what we need is a repository. So let's define one. Let's create a repository package. Let's create a result repository. It should be interface. Let's extend this class with GPA repository. Let's see now. We need type and ID. Okay. Our type is result entity. Our key will be of type string, right? This GPA repository interface gives us out of the box. Sorry, we should use implement here. Okay, extends, because this is an interface, and to use extends to extend other interfaces. My bad, sorry. I want to show you we have out of the box here some methods: save and flush, delete in batch. We can pass iterable here. Some collections extend iterable, so like collection interfaces. We can delete in batch. We can get by ID, get reference by ID, and find all. We have find all, and so on. So we should not define them here, because all this repository is empty for now. We can implement our queries here, but for now we will use those implemented here in the GPA repository. In the service, we should use this we will dependency injection here for the repository. We will use constructor injection. Okay. So we calculate the result here, and we are creating the DTO from the result and the input. Let us save this result repository, save, and it is expecting entity, so we should create a result entity. Okay, and we need an ID. The ID will be input DTO, the number, and we need the result DTO. Here it should be string, so we'll call string value of. Okay, and we'll save this entity, but we will return the result DTO here. So let me run the application. Okay, I don't want some breakpoints to be executed, so I'll delete them. Oh, not just disable them. I don't need them at all. So let me try. Okay, let's see now the Redis command. Okay, we have some hashes here. Okay, with ID some generated value here, like UID, and here is our result DTO. The input number is 2, the power is 2, and the result is 4, right? So actually, now the configuration is working. We have configured Redis. Let's recap this. We need those dependencies. Spring Boot starter Redis. Let use to connect to the Redis server. We need the Spring Boot starter GPA, and we need to install Redis server on our local machine from this link here. So we have done that. We have defined entity which is called which is annotated with Redis hash, and it's called result. So here is this key name result. Okay, we can change it from here and search by this key. See result. The hash is again with name result and some ID. Here is our class. You can see here the package name and the result entity. And the result entity has those fields. So it has ID, result DTO, result DTO, and this is it. So we should do some trick here. What we want to achieve here is now we have this function, right? And we want when x parameter is passed to define it in a key for Redis. For example, for the input 5, if we have it in Redis database, if we have it here in the input here, for example, if we have 5 here, to return the result. But this is not correct because we have number and power now. So we should concatenate those two and make it a key for Redis. And when we have a key, for example, if we have the number 2 to the power of 5, we should make some ID by ourselves, which is something like this, and persist that in the database. And we know this is the number, this is the power, and this will be a key in Redis. And if this key is present, we can return this result here, and this will be the ID. This here will be the ID. So this is the plan how we should do this. Let me delete those drawings, and what we need to do is when we create this result entity for the ID, we don't have the auto-generated ID by Redis. We should pass it, and like I said, I want to define a key concatenated with the number from the DTO. I will use I can use string format or just concatenate the two numbers. I want the number and the power. Okay, I want to pass this key here, and I want the result DTO. So if I have this key, for example, we had received an input to the power of 5, the key will look this way, and this will be persisted in Redis. And we will search for this key. If we find a key for this result, we will return the result, and we will not calculate it, right? So let us try this logic. So we have concatenated the key here. We pass it here for the ID into race entity, and let us check if this works. Okay, let us delete those keys and execute one request. Okay, you can see we have ID for the ID, our key now, which is composed by appending the number and the power. So we can search by this input, and we can return directly the result here without calculating it again. By this we will save calculating power, and if you use cloud, for example, we will save money. So the key composition is working. So what we should do right here is first, before calculating something, because here is the calculation in the workflow, we should check the result repository exists by we should pass the key. Okay, and if we have the key, we should return the result directly. A second. Okay, we put if else block here. If we have the result, we will return from the result repository get reference by ID, and we will pass the key here. Let me see what is not okay. This is yeah, this is actually a DTO here. We return DTO from this function, and this returns an result entity, so we should transform this into a result DTO, so we can introduce one more constructor here. Okay, which will take result entity and it will take the result, and we want the input DTO in the result entity. Okay, let me check the result is double in this DTO. Okay, it is double. So we are going back to the service, and we will take the DTO here. Second. Okay, so the return statement to introduce a variable. We return result DTO by passing the result entity. So we will go into the debug here after second. If this is not the case, let me stop the server. If this is not the case, we want to calculate the result, right? But this variable scope is should be larger, should be broad. Which, okay. So result will be calculated in case it is not persisted in the database. I think the logic is right, and if it is calculated, if we calculate the result, we should create DTO, create entity again, and persist it in the database. This is the first flow, and we can do this way. Actually, we can move the entity here. And say we want to use one reference. Okay, we can make this DTO one-liner. Yeah, there's a bit of composition of functions, but it is more readable, less lines of code, and we save actually we cannot do this because we must return DTO, so I will extract it again. Okay, we should return it. Right. And we should create entity, but we can do this one-liner here to be more readable. Okay, so now the result, either it will be 0 or it will be calculated, but they tell me to delete it because if it is not, if it is calculated in the sales block, we will return from here, and if we go here, the code execution will stop here, so the result is not used in the scope, and it will be always initialized in this case, because this the give us the chance to don't initialize it right here, right? Because it will be always initialized right here because of this return statement here. Okay, those are important things, and let's try this right now. We will stop the program in debug here. We will try to pass. We'll try to pass 5 to the power of 2 first. We should not have this key. So here is the key. Oops, we don't. We have an error actually. Let me see why. Some life revolving. Okay. Let me try again. Let's erase also. Let's keep going here. Okay. Let's delete the keys from the hash. We send 5 here. And okay, we have calculated the result. We did not enter this block because we don't have this key in the database, right? And now we will return on the endpoint. We return this response, and now we expect here in Redis to have this key. See, the key says we have the number 5 to the power of 2, and we have the input DTO here and the result DTO. We have the number 5, we have the power. This is composed into a key, because now we know we have f of 5 to the power of 2, right? And for this input we make this key. Sorry for repeating myself, but I want to be very clear what we are doing. And for example, in the Redis server we have this key, and we search by this key, and we have the result for this input. If we have only this for key, we are not sure the user what power he used for a parameter, and it will be not right to have only this key. We need both of these concatenated, because we can have the same result 25 but with different inputs here, and it will be not correct to return this result then, because I think it is clear. And what we take the advantage here, if we have many clients, I would say see here, see, many clients which are communicating with our web service and want to use this function. Imagine this is something special. It is not just this elementary function, and all of them want us from us some calculations. We can store them in Redis, and we will not use calculation power here if you already have the keys for some calculation which are done in the past. For example, this user want us to calculate 5 to the number of 2, and the other client wants the same, and we will just return it from Redis without coming here to calculate it again. And even in this function, if you say rise this number to this number, if we save the time to calculate this again, we will gain a lot of performance here. So this is the whole logic behind this. So let's try it again. We have the key now. Let's execute this request again. So I expect here this will be in the database, this key. But we have an exception. Let me see what it is. No such method. Okay, we should define no constructor argument in the result detail, right? Select none. Let's wait for the live reward to the server. Done. Let us try again. We should tackle those kind of errors. Okay, this time we don't have an exception, and the key is present. So if it is present, we can fetch it, and we know the result entity will be not now. Okay, we can see the result entity right now. Here it is. We have the ID, 5 is raised to the power of 2. We have the result from this input, it's 25. We have the input DTO information also. We can double check this right. The number right here is 5, the power is 2. And now let us go into the result DTO. And we can see here, we will create the DTO from the entity. This is not the best practice because we coupled those objects. They are not tools decoupled anymore, but for the educational purposes, I do it this way, it's more easy, but we should use getters and setters here. We refactor it, okay. Because don't do this. It can be easier, but we are doing high couple application right now. It's not loosely coupled because this result entity is now a dependency of this DTO, and it is not good practice to do this. But anyway, we are constructing the entity from the DTO. Okay, we can see this right now. Result entity is with the proper information, and we just return from here, and we don't execute again this expensive calculation, right? Okay, we return from here, we have again the result, and this was the thing we want to achieve. And you see, if I try for example to the power of 2, okay, we will calculate the result, right? You can see the key is 2. We will save the result, we will return it here. We can check Redis again. Let's refresh it. Here is a new hash, and we have the result 4. Now we can say we want number 4 to the power of 1, right? The result should be again 4, but this will not work right now. We will now go into the database because the key is 4 to the power of 1, and we will again should calculate the result even if we have it, because the input and the result is important to be consistent. And this trick we have done by concatenate the input right here and use it as a key for the ID in Redis, right? You can use this technique for many purposes, and it's widely used. And okay, we have again result 4. We open Redis, we search for keys. See here, we have the result 4. We have the result 4, but the input and the power are different. And if you have the task to maintain this, if you don't use this concatenation, you cannot achieve it. When you know this technique, it will be more easy for you. For example, you can have some in other real case, you can have a resource, for example, Kubernetes resource, some ID, and you want to make a lock on those Kubernetes resources. And if you use only the IDs, for example, you want to log the resource by ID in Java. You log, for example, some Kubernetes config map object, and it's with ID1, but you have for example a service which is with ID1, and you lock both of them this way, and you can say compose me key with the ID1 and this ID1 is of type config map, and so on. This can be used a lot for walking and other purposes for this here. And in this video I show you how you can save calculation resources using Redis, how to configure Redis, and in the end of the video let's try to use a Docker container. I'm pretty sure it will work. So I have a command here. I'll break it down for you. So now we can see we can connect because I should stop the database. Now we cannot connect it to it, and now you should have Docker. I will run Docker desktop. It is the more lame approach. On Linux I don't use Docker desktop at all. When you run this command, if you have Docker, if you have Docker and don't have the image, for example, okay, I have a lot of images, but if you don't have the image locally, if you run this command docker run, it will download the image for you. If you don't have it, just define some name here, Redis database. This P here is for the port. The left side of the two dots is the port on our localhost, which we will connect our Spring Boot application. And the port of the right side here defined is from the container. And we can expose this port from the container to other port on our localhost. For example, this can be something else, for example 2020, right? This is the port definition here. So let's run this, and this here is for the touch mode. We don't want to go into the console of this application of the Redis database. The other types are IT for interactive mode and so on. Okay, the touch mode. Let us continue using our terminal. This is the hash key of the container. We can check the containers here. Okay, we have a container created from the Redis image with container ID of this, and created 20 seconds ago, and it is up from 90 seconds. You can see here the port which is exposed onto the local host, and the name of the container. So let's try to connect right now. If it work. There are some network issues that can arise here, but let's try this. First, let's connect from here. You can see the keys are not here, but we are connected to the database because it is a different database. The keys are not here. And let's refresh this. We are connected to the container right now, but let us see if Spring can make the connection. Okay, it can. Let's see, we have this key, and if I try another key, for example, or 4, to create another key, here we have created. So now we don't use our localhost Redis. We are using a Docker container, and if you want to read more, about how to run this container, write in Google run Redis container, go to the Redis website, and here are the commands you need to run it. You can use the Docker CLI command line tool to do some queries and so on. And this is the practical part, how to chase your application with Redis. And the Redis database is really powerful. It's the most fastest database in the world right now. It is developed by Netflix, and it's in-memory database, and it is widely used for caching and also for sessions, for maintaining sessions, and so on. You can read about it, but this is the practical part, and believe me, it is not easy to configure it right, because the sources on the web are not in one place. You should go to 3 places, read and configure it properly. Even this basic configuration here is hard to make it working. And this is it. And have in mind, this is for Spring versions from 3 above, Spring version. I'm not sure if this configuration which we have done here will work with Spring 2, for example. And this is it, guys. If you don't have the implementation for this service, I will link the description the link for the video to have the starting point for this implementation of Redis. Okay, thank you for watching, and have a nice day or night, I don't know. Bye.